Hi there, folks. Today we're looking at rewriting equations and formulas. This is also known as literal equations. So if you ever hear that term, a literal equation is more like a formula where essentially we have more variables than we do numbers most of the time. The numbers are very limited. So literal equations, we're literally going to leave the things in terms of the operations that we see. So for example, if I look at this first one is not a literal equation, all right? It's not an equation or formula. This is what we're used to solving, all right? And so when we're doing something like this, remember, the idea is you go backwards through order of operations and you undo the operations as we go. So we're solving for x. So I undo addition first by subtracting the 5. And when I do that, I have 2x equals, this now says 11 minus 5. It literally says 11 minus 5, but we write it as 6 because that's what 11 minus 5 is, okay? And now I undo multiplication by dividing, so I divide each side by 2. See, to undo multiplying by 2, I divide by 2. So I end up with x equals, now this literally says 6 divided by 2, but we rewrite it as 3 because that's what 6 divided by 2 is, okay? If we do the same thing, this is pretty much the same example, but instead of a 2, I have an A. Instead of a 5, I have a B. Instead of 11, I have a C. But I approach it the same way if I want to solve for x. Again, undo order of operations, working backwards order of operations, undoing them as I go. So I undo the addition first, and I undo addition by subtracting. And since the thing I am adding is a B, to solve, I'm going to subtract a B. So now I have AX equals, now this literally says C minus B. And I can't do C minus B. I can't actually subtract those things, all right, because they are not like terms. So instead of writing like in the previous example, I had 11 minus 5, which is a 6. But this time I can't do C minus B, so I literally write C minus B, okay? I write it in terms of what it literally is, all right? That's why they're called the literal equations. If I take the next step now, I have A times X. To undo multiplication, I do division. So to undo multiplying by A, I divide by A. And now this literally says C minus B divided by A. And I can't simplify any of that, so I leave it as C minus B divided by A. Okay? I leave it literally as the operations with which I was dealing, okay? And so that's the idea here. It's the same thing. In fact, technically, it should be easier than what we've been doing because we don't have to simplify at all. We just leave it in terms of the operations, all right? So when rewriting equations and formulas, leave the answer in terms of the operations of the variables, all right? For example, if I look at another one here, and this one has some numbers involved, okay, but it's got more variables than we're used to. We're used to one variable. And so this time I want to solve for y. And so you got to think about what's happening to y. See, the y is being multiplied by this 2, and then we're adding this entire 3x, okay? So to undo all of that, I say, okay, we undo the addition first by subtracting. And the thing we're adding is the entire 3x, so I subtract the entire 3x. So now here that gives me a 2y equals, I can't do 8 minus 3x because they're not like terms, so I have to leave it literally as 8 minus 3x. And you could write that as negative 3x plus 8, which would benefit you in the future. So I'm going to rewrite it that way as negative 3x plus 8 instead. There's not a requirement here. You can leave it as 8 minus 3x. But trust me when I say that will be something that you'll want to do in the future. And really, it's descending order. We start with the biggest x value and work our way down to the smallest. Since 8 doesn't have one, it should go second, okay? But again, not a big deal. Now, I'm going to divide by the 2. So to solve this thing, I divide each side by 2. And I can literally leave it as negative 3x plus 8 divided by 2. And that would be a perfectly acceptable answer. You could also use your distributive property here and say, hey, let's do the negative 3 divided by 2. That's negative 3 over 2. Let's do the 8 divided by 2, and that's a 4 That would be the answer we would see a little bit more often for a question like this, okay? Only because that is a format that we're going to seek out in the future, all right? So at some point, we're going to be seeking out that format that I just wrote, but really, you could leave it as the negative 3x plus 8 over 2, okay? That's the math type of example where we use that a lot, okay? But you'll use this a lot in things like science, all right? In science, you're always rearranging formulas to get them solved for the thing you want. I've used another math formula here, but the application, you'll do this a lot in science, okay? So for example, if I look at this one, here's an actual formula. Let me rewrite it so I have a little space to work. And so this says A equals 1/2 times B times H, all right? And just like any other equation we've solved before, the first thing I notice is a fraction, and I want to get rid of that fraction. Remember, you can always get rid of fractions for any equation ever by multiplying by the common denominator. Since there is only one denominator, the common denominator is a 2. So I'm going to multiply each side by 2. And what happens, because multiplication can be done in any order, I'm going to do the 1/2 times the 2, which gives me a 1. So it cancels out. So I end up with 2a equals b times h. And now I want to solve for b, and right now it's b times h, so to undo multiplying by h, I have to divide by h. And what this now literally says is 2 times a divided by h, so I leave it as 2 times a divided by h. That's my answer for this when I leave it literally, okay? And maybe I'd rewrite it as b equals 2a over h. But now I have a formula for the base. This is actually the area of a triangle, okay? Now I have a formula that's solved for the base of the triangle when given the area, okay? Here's a great type of science example. So this is the formula for degrees Fahrenheit to degrees Celsius. And I'm going to solve it for F, essentially giving the formula that gives me, that I can plug degrees Celsius and get Fahrenheit out, okay? So when we have these two different measurements, it's nice to be able to go back and forth, all right? We wouldn't want to use the same equation. Depends on what we have. If we have degrees Fahrenheit and we want degrees Celsius, we have the formula for that. But maybe I want the other formula that's solved for F. So again, working backwards through order of operations. Actually, let me rewrite this guy first. So I see a fraction there, and you're probably looking at that going, I don't like that fraction. And we could get rid of that fraction out of the gate, or you can distribute right out of the gate. Most of you, I think, are going to feel a little bit more comfortable distributing. And when we do that, we get C equals 9/5 F minus, if you need to take that off to the side, remember 9 over 5 times, that's 32 over 1. You just do numerator times the numerator, denominator times the denominator here. So for this one, we're just going to take the 9 times that 32, and that gives us a 288. And use your calculator for that. The 5 times the 1 gives us a 5, okay? And I've just gone ahead and written it down there. Now you might look at this and go, okay, let's get rid of these fractions. Multiply by the common denominator, multiply each side by 5. You can always get rid of fractions by multiplying by 5. And so far we haven't done anything other than deal with numbers here. So let's distribute this guy. Remember that a fraction bar is a division sign. That says 9 divided by 5. So the divided by 5 and the times 5 cancel out. So you're left with a 9, so 9F. Here, the divided by 5 and the times 5 cancel out, so I'm left with the 288. All right? And now, to solve this thing for F, remember I undo subtraction first, so to undo subtracting a 288, I'm going to add 288. And the big difference between this and other equations is when I look at 5c plus 288, I can't simplify that. I have to leave it in literal terms and say, oh, that's 5c plus 288. That's what it literally says, so that's what I write down. And now to undo multiplying by 9, I divide each side by 9. And so I divide each side by 9. Let me write it up here. I end up with 5c plus 288 over 9 equals the F. And that would be a perfectly acceptable way to write this. You could say F equals 5C plus 288 all over 9. And that would be your answer. If you want to write it like the format that we're kind of heading towards, distributive property, 5 divided by 9 is literally 5 over 9. 288 divided by 9 is going to give me a 32, I believe. Oh, if I could write, it'd be a 32. And now it looks a little bit more in terms of the structure of the original. So there it is. Okay, but either one of these would be an acceptable answer. Yes, the second one looks more like the original problem, so it might be a little bit more useful, and it's a little bit simplified in terms of that. But hopefully you understand the purpose of this. See, the first equation, we plug in degrees Fahrenheit, and it gives us degrees Celsius. But by rearranging it, now I can plug in degrees Celsius and get degrees Fahrenheit. So each of these formulas has its place and is very important. Okay. So again, literal equations, we're still doing the same thing that we've been doing, working backwards to order of operations to solve, undoing operations as we go, but we just can't simplify as we go, all right? We have to leave it in terms of the literal operations that we are doing, okay?